Hey everyone, welcome to this explainer. If you own property, you already know the golden rule, right? Keep the water out. It's step one. But today, we're going to look at exactly how technical engineering and honestly, some highly specific chemistry are used to save roofs in one of the most demanding environments out there, the harsh Highveld climate of Midrand, South Africa. Because let's face it, it takes a lot more than just slapping on a coat of paint to keep a building completely dry. We're going to unpack the fascinating science behind how professional waterproofing actually gets the job done. Here's a quick look at the journey we're taking today. 1. The Midrand Weather Challenge. 2. Why high-valve roofs fail. 3. Comparing waterproofing systems. 4. The professional repair process. And finally, 5. Essential roof maintenance.
All right, let's dive into Section 1, the Midrand Weather Challenge, a climate of extremes. So I want you to really think about this for a second. Why do roofs actually leak? Most of us just picture this massive rogue hailstone punching a literal hole in the roof, or maybe a tile getting blown off in the wind. But the actual science of roof degradation, it's way more subtle than that, and it's happening every single day right over our heads. It's just this quiet, relentless breakdown.
Just think about the conditions out there. Midrand experiences these massive, extreme daily temperature swings. And what does that do? It causes intense thermal expansion and contraction. As your roof bakes in the blazing sun all day and then cools down super rapidly at night, the structure physically moves. This continual movement places immense stress on the overlapping sections of your waterproofing membranes and the mortar on your roof ridges. Over time, it opens up these tiny, microscopic hairline cracks. Add in the unrelenting UV radiation that literally breaks down unprotected materials, followed by those famously severe Highveld rainstorms, well, it's a recipe for disaster. Those hairline cracks just act as entryways, widening with every single daily cycle until the water inevitably finds a way in.
Which brings us to Section 2, why high-veld roofs fail, the hidden destruction.
Okay, let's talk numbers. Specifically, this absolutely crucial mathematical ratio, 1 to 80. If you've got a flat concrete roof, this is the absolute bare minimum slope, or fall, needed to actually push water toward the outlets. If a roof falls even a little bit short of this 1 to 80 gradient, water just starts to pond at the low points. And standing water? That is literally a roof's worst nightmare. It rapidly accelerates the UV breakdown of unprotected bitumen, and it drastically speeds up the carbonation, which is basically a chalky breakdown of your exposed concrete screed. If you don't have this slope built in, contractors actually have to build it themselves using a tapered screed correction before they can even think about applying any waterproofing.
And man, here is a perfect example of just how sneaky water can be. Let's say the flashing fails around a chimney or maybe a parapet wall. The water doesn't just drop straight down. No, it uses capillary action and gravity to track along your internal timber rafters. It travels completely unseen through the dark cavities of your roof, sometimes for meters and meters, before it finally drops down and stains your ceiling. By the time you look up and see that dreaded brown water spot in your living room, the actual failure point could be incredibly far away, and the internal damage, yeah, it's already done.
Let's move to Section 3, comparing waterproofing systems, the technical solutions.
So the whole trick here is matching the exact right chemical system to the specific roof. Check out how these systems stack up against each other. Torch-on bitumen? It's an absolute beast. You're looking at a solid 4 mm thickness, making it highly abrasion resistant, which is perfect for flat roofs that get a lot of foot traffic during maintenance. Now compare that with liquid polyurethane. It's thinner, sure, at 1.5 to 2 mm, but it cures into a completely seamless layer. No seams means no weak points, making polyurethane incredible for roofs with really complex detailing where overlaps would just be a massive vulnerability. Finally, you've got acrylic membranes. These are the thinnest at 1 to 1.5 millimeters, and they definitely require regular top coats to maintain their UV rating. And speaking of UV ratings, polyurethane is excellent right out of the bucket, while bitumen actually needs a cap sheet to get a good rating. Basically, each system is a highly specialized tool engineered for a specific job.
All right, Section 4, the professional repair process, order conquering chaos.
Now, this is the strict 5-step sequence that dictates a truly professional installation. First up, you have mechanical grinding and high-pressure washing to completely strip away the old, failing layers and any debris. Then comes step 2, and this one is huge, mandatory moisture testing. If a contractor skips this, moisture trapped in the concrete will eventually heat up in the sun, expand as vapor, and cause your brand new bitumen membrane to bubble and fail completely. Once it's confirmed perfectly dry, a deep penetrating primer is applied to seal up any porosity. Only then is the actual membrane installed, meticulously closing every vertical turn-up and pipe penetration. And finally, before anyone signs off on the job, a 24-hour flood test is conducted to prove the installation actually, holds water. I actually want to pause on that application phase for just a second, because precision here is literally what keeps the water out. When they're applying a torch-on bitumen system, a contractor has to maintain exactly 100 mm overlap on the sides of the roll and 150 mm overlap at the ends. And these laps aren't just glued down, they are fully heat-welded together. This physically fuses the adjoining sheets into a single, impenetrable, monolithic layer across the entire roof surface. When it's done right, it is honestly a masterpiece of technical construction.
Which brings us to our final section, Section 5, Essential Roof Maintenance, Protecting Your Investment.
Look, if you want your roof to actually reach its maximum expected lifespan, timing is absolutely everything. Every 6 months? Super simple. Just clear your gutters and outlets of leaves and sediment. Remember, blocked outlets cause that destructive water ponding we talked about earlier. Annually, you need to inspect those structural movement joints. If they start to separate, they transfer all that stress directly onto your waterproofing membrane. Then, every 5 to 7 years, you absolutely must reapply UV reflective top coats to your acrylic and polyurethane systems to protect them from sun degradation. If you follow this schedule, you can easily achieve that total expected system lifespan of 8 to 15 years. The experts over at Logiline Waterproofing really hit the nail on the head with this. Don't wait for the next Highveld storm to find your roof's weak point. It makes so much sense. They actually provide these incredibly precise SANS-aligned installations across all of Gauteng, completely backed by a workmanship warranty. You can even give them a ring at 081-016-3479 for a free on-site assessment in Midrand to help diagnose these hidden issues before they blow up into major problems. So I'm going to leave you with this one final thought. Considering everything we've just unpacked about daily thermal expansion, those sneaky hairline cracks, and constant structural movement, is your roof quietly failing right now, just waiting for the next Midrand storm to strike? Don't wait until you're forced to react to a flooded living room. Be proactive, protect your investment, and keep the water out. Thank you so much for joining me on this explainer, and as always, keep learning.